everyone, I Dr. Smita Rani Bhardiya from University Teaching Department, Chhattisgarh Swami Vivekanand Technical University Bhilai welcomes you on this Swayam course entitled Fundamentals of Physics. Lecture number is 39 and the topic of this lecture is carbon bulky wall, quantum dots and carbon nanotubes, properties and its application. In previous class we have already discussed about what is the nanophysics, what are the fabrications of nanomaterials, what are the different method of preparation of nanomaterials. Let us start this lecture with the nanotechnology. What is the definition of nanotechnology? Nanotechnology is a multidisciplinary field that involves the manipulation and engineering of materials at the atom and molecular scale, typically within the range of 1 to 100 nanometers. A nanometer is 1 billionth of a meter, which means nanotechnology operates at a scale far smaller than the width of a human hair. This tiny scale enables the creation materials, devices and the system with a noble properties and functionalities that are not possible at longer scale. The scope and application, let us discuss about the scope and application. First is in the medical field. Nanotechnology has transformative potential in the medicine through its ability to enhance the diagnostic techniques, develop targeted drug delivery system and create advanced imaging technologies. Nanoparticles can be engineered to specifically target disease cell, minimizing side effect and improving the effectiveness of a treatment. For an example, nanomaterials can deliver chemotherapy drug directly to the cancer cell, reducing damage to health tissue. Additionally, nanotechnology enables the development of highly sensitive diagnostic tools that can detect diseases at a very early stage, potentially before the symptoms even appears. The second application is in the field of electronics. In the realm of electronics, nanotechnology has led to significant advancement in the development of smaller, faster and more effective electronic components. The nanomaterials such as carbon nanomaterials and quantum dots are being used to create transistors, memory devices and a sensor with enhanced performance characteristics. These advancements contributes to the minimization of an electronic device, resulting in a more power and compact consumer electronics, including smartphones, laptops and wireless technologies. Furthermore, the nanotechnology is improving the energy efficiency of the electronic device by enabling better heat dissipation and reduce power consumption. Third one is the field of energy. Nanotechnology is also revolutionizing energy production, storage and efficiency. In the field of renewable energy, nanomaterials are being used to enhance the efficiency of solar cell by increasing light absorption and improving charge transport. Nanotechnology is also contributing to the development of more efficient and durable batteries and supercapacitors, which can store and deliver energy more effectively. Additionally, nanomaterials are being explored for their potential to improve the performance of a fuel cell and hydrogen storage system, supporting the transitions to cleaner energy sources. What are the key benefits? First one is enhanced properties. At the nanoscale, materials often exhibit unique physical, chemical, biological properties that differ significantly from their bulk counterparts. For instance, nanoparticle can have increased strength, improved electric conductivity and enhanced reactivity. Precision and control. Nanotechnology enhances the precise control over material properties and processes, allowing for the development of highly specialized and functionalized products. This precision can lead to innovation across various fields including biomedical, medicine, electronics and environmental science. Interdisciplinary collaboration. Nanotechnology inherently interdisciplinary, involving chemistry, physics, biology, engineering and material science. This collaboration fosters innovation and drives process in a wide range of application. What are the challenges and future directions? Despite its potential, nanotechnology also faces challenges such as concerns about the toxicity, environmental impact and the ethical consideration. Ongoing research aims to address these issues, ensuring that the nanotechnology can be developed and applied safely and responsibility. As the field continues to evolve, advancement in the nanotechnology are expected to drive significant process in science and technology, shaping the future of a various industry and improving quality of a life globally. Let's discuss about the what is and the overview of carbon bulky ball. What is it? Carbon bulky balls are a class of spherical nanoparticles preliminarily composed of a carbon. They are known for their distinctive structure features and can vary in the size from nanometers to micrometers. These nanoparticles are a type of carbon nanostructure that exhibits unique properties due to their spherical shape and the carbon composition, making them of a significant interest in a various specific and industrial applications. What are the properties of carbon bulky ball? Carbon bulky balls are spherical in shape, which contributes to their uniform size distribution in a spherical form, ensuring that these nanoparticles possess a very consistent geometrical structure, which is crucial for many applications. The size of these particles can range from a few nanometers to several micrometers, allowing for the flexibility in their uses across different fields. This size range facilitates their integration into a various systems and technologies, from nanoelectronics to drug delivery. The second point is surface area. One of the most notable features of the carbon bulky ball is their high surface area to volume ratio. The spherical shape and a small size of these nanoparticles provides a large surface area relative to their volume. This high surface area is advantageous for the application that require increased surface interaction, such as catalysis property, adsorption and the sensing. In the catalysis, for example, the high surface area allows for the more active side to be available and enhancing the efficiency of chemical reaction. The third part is mechanical strength. Carbon bulky balls exhibit remarkable mechanical strength and stability. This carbon atom within these nanoparticles are bonded in a way that imparts durability and resilience to the structure. These mechanical robustness makes them suitable for use in the application that demands high strength, such as reinforcement material in the composite or as a structure element in various technologies. The stability of these nanoparticles also contributes to their longevity and effectiveness in the different environmental applications. What are the applications of this carbon bulky ball? The nanode composite, the formation of nanocomposite. Due to their mechanical strength and high surface area, carbon bulky balls are used in the development of advanced nanocomposite. These nanocomposite benefit from enhance the properties of nanoparticle, including improved mechanical performance, increased thermal stability and enhanced electrical conductivity, such as composite, and find application in the aerospace, automotive and the sports equipment, where lightweight and high strength materials are required. Catalysis. In the field of catalysis, in catalytic properties, carbon bulky ball can serve as a catalyst or the catalyst supporters. Their large surface area allow for the more efficient catalysis, as a more reactant molecule can interact with the catalytic sites. This property is particularly valuable in industrial process, where the efficient and selective chemical transformations are required. The third one is in the field of electronics and energy storage. The unique properties of carbon bulky ball makes them suitable for use in the electronic devices and energy storage system. In electronics, their high surface area and mechanical strength can enhance the performance of components such as electrodes and conductive material. In energy storage, they can improve the efficiency and capacity of batteries and supercapacitors by providing better conductivity and structural support. Biomedical application. In the biomedical field, carbon bulky ball have potential uses in the drug delivery and imaging. Their spherical shape and the high surface area allow for the effective loading and targeted delivery of the therapeutic agent. Additionally, their mechanical stability ensuring that they can withstand the biological environment while performing their intended functions. Carbon bulky balls represent a fascinating area of nanotechnology due to their unique properties and versatile application. Their spherical shape, high surface area and the mechanical strength makes them valuable in a wide range of fields, from material science to the biomedical or biomedicine. As a research continues to explore and exploit their properties, carbon bulky balls are expected to play an increasingly significant role in advancing nanotechnology and improving various industries and scientific process. We have already discussed about the carbon bulky ball. Now we will discuss about what is the carbon dot. Carbon dots are nanoscale semiconductor particles that exhibit unique optical and electronic properties due to their size and composition. These nanoparticles typically range from 2 to 10 nanometers in the diameter and are known for their distinct quantum confinement effect, which arises from their extremely small size. This quantum confinement leads to size dependent optical properties that make quantum dots versatile and valuable in various technologies and specific and scientific applications. Now let us discuss about what are the properties of quantum dots. First is size and composition. The size and composition of quantum dots can be finely tuned during their synthesis, allowing for precise control over their properties. The size of quantum dots typically ranging from, as discussed, 2 to 10 nanometers, and their optical and electronic behavior change with the size smaller quantum dots. Smaller quantum dots emits the light at shorter wavelength, that is blue, while the larger dots emit light at larger wavelength, that is red. The size dependent emission is direct result of the quantum confinement effect, where the electronic property of the dots are altered due to their small size. Additionally, the composition of quantum dots, such as the choice of semiconductors material, that is cadmium, selenide and indium phosphide, further the influences their optical and electronic characteristics. The second property is photoluminescence. Quantum dots are renowned for their photoluminescence, which refers to their ability to emit the light of a specific wavelength when they are excited by an external energy source such as UV light. The emitted light's wavelength is dependent on the quantum dot size and material composition. For instance, quantum dots of a different sizes can emit a range of colors from blue to red, making them useful for the various applications that require precise color control. The tunable photoluminescence is due to the quantum confinement effect, which restricts the movement of electron and holes within the dot, leading to discrete energy level and specific emissions wavelength. Third one is high stability. Quantum dots exhibit high stability under various experimental conditions, such as which is a critical factor for their practical uses. They possess an excellent photo stability, meaning they can withstand the prolonged exposure to light without significant degradation or the loss of their optical properties. This stability is due to their robust semiconductor core and protective cell that minimizes photo bleaching and maintain performance over the time. They possess the excellent photo stability, measuring they can withstand prolonged exposure to light without significant degradation or the loss of their optical properties. This stability is due to their robust semiconductor core and protective shell that minimizes photo bleaching, maintain the performance over the time. The high stability of quantum dots makes them suitable for long-term application, such as in imaging and sensing, where the consistent and reliable performance is essential. The applications of quantum dots versus biological imaging. The quantum dots are extensively used in biological imaging due to their size tunable photoluminescence property. They serve as a fluorescent marker that can be attached to a specific biomolecule or the cell, allowing for a high resolution imaging and the tracking in biological system. Extensively used in the biological imaging due to their size tunable photoluminescence character. They serve as a fluorescent marker that can be attached to a specific biomolecule or the cell, allowing for the high resolution imaging and tracking in the biological system. Their ability to emit multiple colors simultaneously makes them valuable for multiplexed imaging, where multiple targets can be visualized in a single experiment. Second one is display and lighting. Quantum dots are employed in the display technologies such as quantum dots display, where they can enhance the color accuracy and brightness. They are used in a backlighting for LEDs and in new types of display to achieve vibrant and precise color reductions. Quantum dots are also utilized in lighting application to produce high quality white light with improved color rendering. Next is solar cell. Quantum dots are explored in the field of photovoltaic to improve the efficiency of solar cell. Their tunable optical properties allows for the better absorption of the sunlight and more efficient energy conservation. Quantum dot based solar cell aims to surpass the efficiency limit of conventional silicon solar cell by utilizing broader range of the solar spectrum. Next one is sensing application. Due to their unique optical properties, quantum dots are employed in the various sensing application, including environment monitoring and chemical detection. They can be used as a sensor that respond to a specific chemical or the biological interaction, providing sensitive and selective detection capabilities. Quantum dots are a fascinating area of a nanotechnology with a range of unique properties and application. Their size, tunable photoluminescence, high stability and the versatility makes them valuable tools in the field of biological imaging, display technology and solar energy and sensing. As research and technology continue to advance, the potential uses of quantum dots are expected to extend, driving innovation and across multiple industries. Let us talk about carbon nanotube. As shown in the figure, carbon nanotubes are cylindrical nanostructure made up of a carbon atom arranged in a hexagonal lattice. They represent a significant advancement in the nanotechnology. Due to their remarkable mechanical, electrical and thermal properties, CNTs come in a two main types, that is single wall nanotubes and other one is multi-wall nanotubes as shown in the figure. Let us define what are the single wall and what are the multi-wall. First is single wall carbon nanotube. Single wall carbon nanotubes consist of a single layer of carbon atom rolled in a cylindrical shape. Their diameter typically range from 0.7 to 2 nanometer, but they can be thousands of nanometers in the length. The unique properties of single wall carbon nanotubes arises from their seamless structure and high aspect ratio. What are the multi-walled carbon nanotubes? As shown in the figure, multi-walled carbon nanotubes consist of a multiple concentric layers of carbon atom arranged in a cylindrical fashion. The layers are separated by a distance of about 0.34 nanometer, similar to the spacing between graphene layer in a graphite. Multi-wall carbon nanotubes generally have a larger diameter than single wall carbon nanotube, ranging from 2 to 100 nanometers, with length extended to the micrometers range. What are the properties of carbon nanotube? First is mechanical property. Carbon nanotubes are renowned for their exceptional mechanical strength and flexibility. They exhibit tensile strength up to 100 times greater than steel while maintaining remarkable flexibility. This strength is due to the strong sp2 hybridized carbon bond in a hexagonal lattice. Carbon nanotube have withstand extreme stress and strain without breaking, making them ideal for application in the requirement of high strain to weight ratio, such as in a composite material and structural reinforcement. Second one is electrical properties. The electrical property of carbon nanotubes are highly dependent on their chirality and a diameter, which affect their electronic bond structure. Carbon nanotubes can be categorized into metallic or the semiconducting type based on their chirality. Metallic carbon nanotubes exhibit high electrical conductivity, making them suitable for the application in the nanoelectronics and conductive material. Semiconducting CNTs have a bond gap that can be tuned by changing their diameter or the chirality, allowing for the application in the transistors and other electronic devices. The ability to control these properties at the nanoscale offers significant potential for the advancement in electronics and optoelectronics. Third one is thermal property. The carbon nanotube possess excellent thermal conductivity, making them effective at dissipating heat. The thermal conductivity of carbon nanotubes can exceed them of a copper thanks to their efficient phenomena transport along the nanotube axis. The property is particularly valuable in the thermal management application such as heat shrink and thermal interfaces in electronic devices. Carbon nanotubes can efficiently conduct heat away from sensitive components, helping to maintain optimal operating temperature and enhance the performance and reliability of electronic system. The carbon nanotube are versatile nanostructure with a range of remarkable properties. Their unique cylindrical structure and hexagonal lattice arrangement endow them with an exceptional mechanical strength, variable electrical conductivity and superior thermal conductivity. These properties make carbon nanotubes valuable in a variety of applications including advanced material, nanoelectronics and the thermal management. The ongoing research and development in carbon nanotechnologies continue to reveal new potential application and enhance their integration into a practices technology, highlighting their importance in the future and nanotechnology and future of nanotechnology and material sciences. Let's talk about what are the various applications of carbon nanotube. As we discussed, carbon nanotube have a lot of application, but we will basically focus on some of its application. First is electronic application. Carbon nanotubes are revolutionizing the electronics industries due to their exceptional electrical properties. Their ability to act as either metallic or the semiconductor material depending on their chirality and diameter makes them ideal for various electronic applications. Carbon nanotubes are employed in the fabrication of high performance transistors where their high electron mobility and scalability enhances faster and more efficient operations compared to traditional silicon based devices. Additionally, carbon nanotubes are used in the development of sensitive sensors for detecting gases, biological molecules and other substrates, owing to their high surface area and conductivity. Interconnect CNTs offer superior performance by providing low resistance pathway for the electrical signal, which enhances the speed of efficiency of electronic circuits. Material science. In material science, carbon nanotubes are utilized as a reinforcement in the composite material to significantly enhance their strength and durability when incorporated into a polymer, metal or the ceramic. Carbon nanotubes improves the mechanical properties of the composite such as tensile strength, impact resistance and the flexibility. This enhancement is due to the strong carbon-carbon bond in between the carbon nanotube, which provide exceptional strength to weight ratio. These reinforced composite find application in various industries. Next one is in the energy storage. Carbon nanotubes play a crucial role in the advancing energy storage technology, particularly in the batteries and supercapacitor. In batteries, carbon nanotubes enhancing the performance by improving the conductivity of the electrodes leading to higher charge and discharge rate. They also increase the overall capacity and lifespan of the batteries. In the supercapacitors, CNTs are used to boost the surface area of the electrodes, which result in the higher energy and power densities. These improvements contribute to more efficient and durability energy storage solution, supporting the development of advanced electronic devices and renewable energy system. The unique property of carbon nanotubes enable significant advancement across the various fields including electronics, material science and energy storage. Let us do a comparative analysis between carbon bulky ball, carbon nanotube and quantum dot. In Field of size and structure, carbon bulky ball. These are the spherical nanoparticle composed of a carbon ranging from the nanometer to micrometer size. Their spherical shape and high surface to volume ratio gives them a unique properties suitable for the specific applications such as environment remediation and catalysis. In quantum dot nanoscale semiconductor particle, which is ranging from 2 to 10 nanometer, they exhibit size dependent optical properties due to quantum confinement effect, making them valuable in imaging and display the technology. In carbon nanotube, cylindrical nanostructure with a hexagonal lattice of carbon atom, they exhibit as a single walled and multiple walled carbon nanotube. Their cylindrical shape and unique mechanical, electrical and thermal properties distinguish them from the other two. CNTs, electrical and thermal conductivity. CNTs excel in the electrical and thermal conductivity, making them ideal for the electronics and thermal management application. They offer a high tensile strength and flexibility, which is beneficial for reinforcement of material and in energy storage device. Carbon nanotube preliminary valued for their tunable optical properties rather than electrical or the thermal conductivity. They are widely used in the application where the controlled light emission and the absorption are the essential. Carbon bulky ball do not exhibit the same level of electrical and thermal conductivity as CNT, but are effective in the application of requiring high surface area and stability, such as environmental sensor and a catalysis application. In case of applications, the carbon bulky balls useful in the environmental application due to their high surface volume, surface area and stability, making them suitable for the use in the sensor and catalysis. Quantum dots are employed in the medical imaging, display the technology and the solar cell due to their size tunable optical properties. Carbon nanotubes are applied in electronics material reinforcement and the energy storage due to their exceptional mechanical, electrical and thermal properties. What are the challenges and future direction? The carbon bulky ball challenges includes the difficulties in the synthesis and scalability, which impact their widespread uses of the application. Carbon dots issues with the toxicity and environmental impact need to be addressed to ensure their high safe uses in the various application. Carbon nanotubes high production cost and difficulties in a large scale fabrication are significant barriers to their broader adaptation. Thank you so much. Thanks for your attention. In next class, we will discuss about what are the astrophysics and its application. Thank you.